Welcome guys to part 10 of our build signal generator with dip function. You can see on your screen that I started off the list of frequencies I made. You can see one point highlighted, that's so far I got yesterday, or no, the day before. And I stopped then. So today I will continue to fill in all the bands. You can see in the red, you can see the bands, what they should be. And so I copied that down from another list, what I made for the frequency meter. So my frequency counter actually, and that puts about 8 in there, so I have to get them all down to, well, it works pretty well actually. So I will change the position of the camera and I will show you what I'm doing, okay? Okay guys, let's have to set it all up. You can see the frequency is at 1.7 and 1.5, and that was the last position on 56. So I have to go back down to 57. I will show you all close up. So hold on, I'll move the camera a bit. Get a bit closer too, otherwise you can't see. Okay. There you go. Anyway guys, our needle is at you can't be, well, you can't really see it because you're not as close in front of it. Anyway, the needle is now at 56. I will put the needle at 57. Yeah, and we have now 1.73, so that's exactly 10 kilohertz higher. No? That is a lie. 20 kilohertz. So I'll put it on my computer. 1.73 megahertz. Okay. That's, yeah, it is 20 kilohertz apart, a bit more. You always will find that it's not going, how you call that, linear up on frequency. It never does that. So always you have a discrepancy from half or 5 kilohertz or something like that. But then again, this you can see also via this connection, you can put a frequency counter on it, and you can do it exactly. So that's the advantage I constructed here. I am able to do, okay? So I go now to 58. I hope he's right. 58. He gives now 1.762. See, that's what I meant, you know. 68. Is that right? No. That's 8, yeah. Okay. That's at 8. Put it down. See, this is an hour's task actually. It's quite some work to do this. 7.5 megahertz. So you have to fill in every step, and then we go to 59. 59 gives you 1.789, so that should actually be 179 actually. But I'm not going to put that down there. Let's have a look and think about that for a minute. Okay, but this is 1.5. Yeah, doesn't matter. See, when you align something, you don't bother about 10 kilohertz or something. If you get it precisely, you can do it precisely. As you can see on my frequency counter, you can do that precisely. So, that's 1.78, 1.78. See, I'm aware of it. That is the case. So when it comes to the push to shove, then we are able to get it 60 now. That's the last one, I think, what I'll do on camera. That is 1.8, exactly, 1.8 exactly. No? Well, no. Think that. See, you can see why I didn't put it straight on there, so you can imagine what it will be when you see the figure. So anyway guys, you get the picture what I'm doing. I will, my transformer is still on the bench, I didn't put them in there. So I decided to make a start on this business, so that will take quite some time to do. So I think I don't really feel like it, but there again it has to be done. So that's part of the job. If you make something, you have to do all of it. So anyway guys, I will come back to you when I have more, okay? Welcome back guys. There you go, you saw the previous part. I was busy with get all the numbers down. Yeah, you can see in front of you all 8 of them. I put them all down on paper. And please inform you every time I go back to that particular number, also the frequency will come up what is on the paper, so that is what the intention is. Okay, you can see that in front of you, so I made a smaller one. Yeah, and I can stick that on top of the signal generators. That's quite a handy something to have on there. So I also can put a smaller digital counter on here. I probably know already about those things. I'll show you. Here, all of them. You can put them on there. I can connect that up at that point. So actually I can make a digital of it. So if I make a little box or something like that, put that in there with a 9-volt battery, we still have our ability to read digitally, so we don't need that list. But anyway, I made them analog. I wanted to have it on paper. I made it on paper, but there again, I still have the possibility of the ability to read, make the readout of a counter like this. So that's still on the how you call that, on the menu. So so far so good guys. I'll reposition the camera and I want to show you something. Okay, there are 3, well, that's heavy, you know. I'll refocus that a bit. So you can see in front of you our parts I'm going to need to make the power supply. You can see, oh, yeah, that's the cheapest ones, those. They're quite expensive, those capacitors. That's one, this one too is also a very expensive capacitor, but they're very reliable. And that's one of the older Philips ones. So, and they are reliable as well. If they are more reliable than those two, I can't say that, but anyway guys, you can see this is 10, this is 22 and this is 47. So that's the capacitors I want to put in. I'm going to put in 4 of those diodes. That is 1 1 November 4007. So the high voltage, 700 volts for all of them, and it grades position. So how do we call that? Yeah, I mount them that way. It's in grades position. So that's what I will do, and then I will show you now what I have done on the back of our apparatus. So look, I just zoom out a little bit, guys, a little bit. That's the refocus. Okay, so I will turn them around. So I'll show you something here. So I positioned the transformer in there. So I would reinforced with this bolt here, reinforce that so that it's sturdy enough, and then I will put some reinforcements on this part. At the other point is when I get the box on, I can drill a couple of holes in here, solder or two nuts, copper nuts on this point. I can do it through and through, and then solder the nuts on here, and then I can fit the bolts in there like that. So it will be another reinforcement that this isn't going to move. So what I want to do is have a look. You can see, yeah, I'm going to mount this thing here, and I will do this way. I'll show you. I will pick this up, move this over, get my pliers like that. Okay, this one too. Like that. And on the other side. Go. There we go. Now we have 4 positions to keep them off the chassis, so that it doesn't short those points out. You see. You can put some bolts in there, but bolts tend to loosen, so I will try to solder 3 points, that point, and this point. Solder that down, first of all mounting our capacitors if need be. I think this one is going to be too big, guys. Have a look, it's massive. Tell you what, I'm going to go down to 33, but this is absolutely ridiculous. It's absolutely, you know how big that is. I don't have any room left. Hold on. Yeah, I get myself another capacitor. I think this is a bit too big, a bit too much off the gut. Let's have a small one here. Yeah, there's a big one as well. That won't work. Tell you what. Put another 22 in there. It doesn't mean a metal, does it? It should be sufficient. Yeah, that should be sufficient. I'm not too worried about that. I have to be. So see, well, it's still big, you know. You can see that yourself. But I have to go in like this. And the other one in front, of course, but that should be okay. See, you have room enough. The 4 diodes I will mount on this point. There's enough room here. They'll be able to do nil. This connection will be up here. It will be connected up to the minus of the minus side of that rectifier. So that will be it. Try to mount a plus here. I have to, they're not small, you know, but this other thing we have to bear in mind, you have to fuse this thing. you have to put the fuses in there. You have to put the fuse before that rectifier, just after the rectifier, put the fuse. I don't want to put that fuse yet, really matter. And then we have another fuse on our primary, you know, if something goes wrong, this thing will be protected. So I always take great care to protect the appliances I make. Okay, and something else, what is a very sensible thing to do, is to put a schematic in a plastic bag inside of the signal generator. So if something goes wrong, you plug this out and you have straight away, you have the schematic. You don't have to look for anything or search for where I have done that or whatever. So I just shove it in there and that's it. Okay. Okay, guys, you can see we came quite a lot, quite a way with our signal generator. We have to cover this up as well. I think I'm going to this has to go in here. I will put another plate along here as I've done on this side, here on this point. Put one on there so to reinforce the box, so we can screw our box together. And we have to make sure that our box is sturdy, that it doesn't get in a funny shape if you pick it up or something like that. That would be very catastrophic. At least it is for this signal generator, that would be. Anyway, guys, you can see we're moving along very nicely, and yeah. I wanted to thank some of you people who did give me a very nice reaction. I'm very pleased that you learned something from it. And don't be shy to ask more questions. If you want more or whatever. Don't be shy, just drop me a line, I will give you an answer. If you want to have schematic, I will have that for you as well. So. Anyway, I want to encourage you to start building. Well, you learn so much from building. I want to also caution you a little bit, and not to put you off, but it looks simple building. It looks very simple, but it's not simple. The main thing is you have to experience what happens when you wire something up. You have to learn that. I will give you a few tips. Static screening, that means separation screening, is always useful, and certainly on valves like this. This is a static shielding, what you have to blind off one side to the other, so that one side can't see the other side, because that is the reason why you get the feedback. Okay. And that concerns also this separation, the separation between our signal generator and our grid dip meter. So you have to separate that as well, and that is still playing a part here. There is separation. You have separation on the other side as well. The other point is to avoid any influence to get when you have a wire what is carrying the voltage go over the top. I'll show you. This voltage carrying wire. So because I don't want to have any influence on the schema, on the hole, on the wiring on the hole, I will go on the other side over the top, so I can stay out of the way of other important parts who are playing a role, so that wire, if I probably would put that part, the other parts, that would have an influence on those parts and vice versa, so you have funny things happening. So that is a way to avoid that. So that's some tips I can give you. Anyway, guys, this is very important. This valve in here, this is a transmitter. So you want to avoid that he starts radiating radio frequency, so that in a couple of blocks further on, as you call it in America, you can receive the signal you are making with the signal generator. It won't be able anyway to radiate that, because it's all boxed in. You can see it is double copper both sides, so everything is connected to ground. So this is double shielding, and then another shielding around that one, so it won't go out. But anyway, guys, if you open up a signal generator, then you are liable to radiate RF, and you shouldn't do that. So you should avoid radiating RF. So well, you are normally hold to a certain standard to adhere to certain rules, and you shouldn't disturb anybody with your frequency. So your neighbor is looking at television, and he has all funny things on his screen because you are mucking about with a signal generator or something like that. In the earlier years, what I know, they were very sharp on that, so very hard on that. So as soon as you cause something like that, they will be onto you like a ton of bricks. So that's the way it was working. And of course, if you had a license and you caused something like that, you were liable to lose your license. So it's just very important that you realize what you're doing anyway. So I don't want to discourage you, I want just to encourage you to start off building. Don't look for projects that are very involved or very difficult. Just start out with some easier projects. So well, easy between brackets. What is easy? See if you have a certain receiver. I can't get to the name again. Oh dear. Anyway, the receiver is not. It's called easy, but he's not easy. Okay, oh yeah. I can't get to the tip of my tongue to say it, but I can't find it. Anyway, guys, sorry about that. But anyway, guys, you can find some schematics, and I want to encourage you to use the valves. Great fun. Mind you, there is another warning again. There is high voltage involved. There are some little valves who are working on the battery voltage, 12 volt. So you can start with that. Anyway, be careful, because they are directly heated. They have the filaments straight as cathode rod. So if you do some funny things with that filament will go. So you only can use direct current on there, not AC current. You can't do that. So but there's more to say. You can use other valves. You can the R valves will work at 45 volts. Anyway, 45 volts can you consider as a high voltage. If you have that wire around the fence for cows or something like that, you get that electric wire that is about 45 volts. And in the past I was urinating against that wire. And when that was switched on, you can imagine what happened. Anyway, that's some funny things, guys. So anyway, yeah, I want to encourage you to have a go, as they say in England. So to have a go. So just yeah. Anyway, it keeps you off the straight, so you don't want to have any trouble be outside. So you will be on your workbench, and you're having great fun. Anyway, and if you can join with other people who want to do the same thing, even better. So you can well, you have this sort a clap or something like that, radio amateur or something like that, and sit together an evening or an afternoon or whatever, and making things, making sure that it works, and understanding what you're doing. Try to understand what you're doing. Then you have great fun. Anyway guys, I'm going to cut off this video again, and I'll come back to you when I finish the job. And then I've done that, I will come back, also will conclude this series of building that signal generator, and then I will come back to you in the near future with a receiver where we're going to do what I've done before in those videos that you saw, and then we will align a receiver. Try to align. I would better say try to align the receiver, because I have an old receiver that is about 16, 17 or 18 years old. All those capacitors were in there. They are out of value, or they're leaking. All the resistors are in there. They are way out of tolerance. So always when you have a receiver like that, you have to measure all the resistors. That's the best thing to do. I've done that always. So, and what I never would do is when I get that thing, oh, it looks very nice, and then plug them in. That's the wrong action. That is asking to blow up your transformer or ruin your rectifier valve or whatever. So never ever do that. Just make sure you have an ohm meter, and you get whether you know there is the plus, or should be the plus of say 400 volts, and you take your ohm meter and you measure nothing or nil, or it just goes through. Like if you put in the pins like this, I'll show you. I'll put them on ohms. Hello. I'd like to show you. Anyway, so you have an ohm meter like this. It says 220k. And this is open, and you know there is resistance. Yeah, there is a resistance of 20k. But as soon as this happens, oh, you can say oh, you have a short. So if you happen to have that on our electrolytic capacitors, you know what's going to happen if you switch that on. And in the past, they didn't have any fuses. They didn't know what that was, apparently. So we always put in fuse. It's always good. Even Ron on the side glass slinger, he always put a fuse in there. And never ever it comes to his mind that he wouldn't use a fuse. When you have a look at Ron at glass slinger, that man is amazing. Absolutely amazing what he's made. You have the last I posted 2 videos on Bakelite the radios. We in Holland we had also Bakelite radios, U-series he called them. Absolutely killers that were. Some people didn't know that the high voltage or the net voltage was on that chassis because they had no transformer, and the filaments were connected in series, so they have the full, then it was 220 volts, now it is 230 volts on there. So if you touch that that chassis, you are liable to get a horrible shock, or you will get killed. So and other people got killed on those things. Anyway, that's all said this. Just have a look at Ron, and Ron, you can learn something from Ron. Anyway, you if you want to have a nice day, you sit down and have a couple of hours with Ron. You really enjoy. I enjoy it anyway. Every time he comes on, he is absolutely a marvelous guy. Anyway, guys, I'm going to shut off the video, as I said a couple of moments ago, and I'll come back to you when I box it all in, see what I can come up with for you. So anyway, so far so good. Anyway, see you later. Okay guys, I put just the diodes in there, so I That is the plus and that's the minus. That are the connections from the transformer. So okay, so we have done that. I'll show you some more. Hold on. I put the capacitors in. There's a 10 and the two 22s. I put a resistor in it for 1.8k. I have a 3k down here on the workbench. Yes, I have to put that one in. So I did a trial on that. It's about 5 milliamps, 6 milliamps, but the whole lot is going to pull out of the transformer. That represents about 9 volts on that resistor, on this one. And that is nearly double it, so that should be about 18 volts. You add them together and you know how much voltage is going to drop on this whole lot. So that would be say 27 volts altogether, a bit more, perhaps a bit less. So I think the transformer, I'll zoom back out on. Zoom back out. There we go. The transformer is 180 volts. I showed you that. And if they take the square root out of there, we can end up with about 30 volts more on this point. So we have to get rid of that voltage, get that down to the voltage of 170 volts or something like that. And then we know from the screen grid we take that measurement, it will drop another 10 volts, so there is 160 volts. So that's about right for that particular valve. Okay. Right guys, so I'm now in the process of connecting up the last leads. I put some fuses in there. On the back side there is a 100 milliamp fuse, and the front is a 500 milliamp fuse. The 100 milliamp fuse is to protect the high voltage from failing. So if something happens to that capacitor, this fuse will go. And if something happens, and on the whole happens, this fuse will go. So this will protect the transformer from the net, and this will protect after the secondary. Okay, so we have a double protection in there. So the only thing what I have to do next is to connect all up. So we'll be zoom back out again. Hold on. Zoom out. Okay. Refocus. Now you can see up here, you see the switch. I have to get that loose, get the power lead on there, this one, and then the other two what I have here on that switch, solder them on and put the switch back, and then with a tie rip get those wires nicely together, and then connect up the transformer on the blue lead and the other one on the fuse, and the other side from the fuse onto the transformer. That's all what has to be done. And now obviously we have to connect up our power lead, put a plug on there. There's still no plug on there, and that will be the lot there, guys. Yeah, we'll put another protection screen in here. I'll get that on this side. I'll put that up there, and then we'll make the box. I'll tell you what, I'm not going to make that box and come back to you with the box on camera. There's not much point, is there? The only thing I wanted to show you, the finishing of the signal generator and dip meter. So I wanted to show you that, and so I'll finish that off, guys. I won't come back now. I will finish off now the video, because the video is already long enough. I will promise you to come back in the next video with our radio, and we're going to realign this radio with this signal generator and dip meter. the point is, I did align this radio already, but I'm not satisfied with how the oscillator is functioning, so there is a discrepancy, and I want to find out what that discrepancy is so that I can make a video of that. I think it will be interesting for you also. So guys, I will thank you for watching. I'm happy to have you on board again, and please, if you want to ask me something or whatever, just drop me a line and I'll try to help, or whatever. I think that will be it for this video, guys. Thank you very much. Give me a thumbs up if you like the video, or subscribe, even better. Anyway guys, the video before this has a miserable picture. I have to find out how I can change that. I only have, when I make the film, I have only three options of that, and those three options are also nothing. So see how I can solve that problem. Okay, thank you very much guys, and I'll see you the next time. Okay.